Welcome. In this video I'm going to be telling you about the derivative of natural log x and why it's 1 over x. And in this video I'm going to be showing you why this is the case using the definition of the derivative. Okay, I'll have a separate video of me showing you this a somewhat easier way using implicit differentiation, which I actually like better because it kind of calls back to what even is natural log. In our class it's the inverse function. But this, I'm going to use the limit definition, and there's going to be some algebra and some log properties and stuff, and it'll be great. So I'm going to start off. I know that the derivative is the limit of rise over run. So that'll be the limit as run goes towards 0 of log of x plus h minus the log of x divided by h. Okay. Now I'm going to use the log property where the difference of two logs is equal to the log of the quotient of the arguments. Okay, so I'll say that's equal to the limit as h approaches 0, and then maybe I'll also just write that as 1 over h next to it, because I'm going to be using another log property. So this is the natural log of x plus h divided by x. Okay. Now while I'm at it, I'm going to be calling this 1 plus h divided by x from here on out. And maybe, because I'm going to be applying another log property, I'll just kind of keep working to the right. This is the limit as h approaches 0 of, I'm going to move this up as an exponent of the thing I'm taking the log of. That's another one of our log properties. It's the power property, I guess. All right, so it's the limit as h goes to 0 of the log of 1 plus h over x to the 1 over h power. Okay. And I'm going to make sure that's definitely clearly an h, because I'm going to, again, make a substitution. And maybe when I was writing up my notes, I should have been a little more careful. I kept choosing n. So I'm going to let n be equal to h divided by x. Okay, I think that's what I'm going to need, yeah. So then I need to figure, so I can get rid of this. I'm going to need to also get rid of this and get it in terms of n and x, I think. So that means 1 over h is going to be equal to, what am I going to do? I'm going to multiply by x, and then I'm going to flip it so it'll be 1 over x, 1 over nx. Okay, I can work with that. And as h goes to 0, what's going to happen to n? N, which is h divided by x, is also going to be going to 0. All right. Now, I'm going to just rewrite that limit over here. This is now the limit as n goes to 0 of the natural log of 1 plus n to the 1 over h is 1 over n times 1 over x power. Right. Now I'm going to apply one of the log properties in reverse. I'm going to say, wait a second, that 1 over x, if it's written as an exponent, I could swing it down around the front. And moreover, I think because 1 over x doesn't care what happens as n goes to 0, right? It's going to be something that I can factor out of the limit. So I'll have 1 over x times the limit as n goes towards 0 of the natural log of, or maybe I'll write it this way to make it a little more clear, 1 plus n to the 1 over n power. and log is a continuous function where it's defined, we're not really looking at any sort of like issue with the domain of log in this situation. So I can pass the limit on through to the inside of that continuous function. So this is going to be 1 over x times the natural log of, the limit as n goes to 0, of 1 plus 1. 1 plus n to the 1 over n. Okay. You may recall I didn't write it up here the same way I did when I was telling you about the derivative of e to the x, but the definition of e that we take in this class is the limit as n goes to 0 of 1 plus n to the 1 over n power. So now I'm working with 1 over x times the natural log of e. And the natural log of e is the special exponent that I put on e to get e. That's going to be the 1 exponent. So I've got 1 over x multiplied by 1. That is 1 over x, as I had hoped to show you in the first place. And so this is why the derivative of natural log of x is 1 over x, really just in terms of the definition of the derivative.